what we're going to look at today is how to solve the system of equation using Gaussian elimination. We're looking for what x sub 1 and x sub 2 is going to be. So our first equation is 3x sub 1 minus x sub 2 equals 2, and our second equation is x sub 1 plus 2x sub 2 equals 10. So using Gaussian elimination means that we have to use matrices. So how we're going to set up our matrix is that we're going to look at the coefficients of our first equation, and that's going to be my first row. So I know that my first row is going to consist of 3, -1, and 2. I know that my second row is going to consist of the coefficients of my second equation, 1, 2, and 10. I'm going to put this line so that I can kind of separate between my equation and my answers. The goal of Gaussian elimination is to turn this left-hand side of 3, -1, 1, and 2 to transform that into the identity matrix. The identity matrix for this 2 by 2 matrix is something that looks as 1, 0, 0, 1, where there's always going to be ones on that main diagonal going from the upper left to the lower right, and every other element is going to be filled with 0. So once we can transform this left-hand side into the identity matrix, the other two answers, instead of 2 and 10, are then going to be their answers for x sub 1 and x sub 2. So the first thing that we need to look at is how can I transform the left-hand side of 3, -1, 1, 2 into the identity matrix. So looking at this, the first thing I would look at is that I already have a 1 in kind of the location that I need. So if I were to kind of switch row 1 and row 2, I'd already have the 1 taken care of. So my first operation is going to be interchanging row 1 with row 2. So now I can now write it as 1, 2, 10, 3, -1, 2. So I'm allowed to interchange those two rows. What I notice now is that I want to turn this 3 into a 0. So the next operation that I want to do, I want to transform row 2. If I take row 2 and subtract it from 3 times row 1, I'll be able to get 3 minus 3, which will give me that 0 that I need. So I have to do it for every single thing in row 2. The first row stays the same, but now I'm looking at that I'm going to say 3 minus 3 times 1, which is going to give me 0. I'm next going to say -1 minus 3 times 2, which is really -1 minus 6, which is going to give me -7. And the last thing I'm going to do is 2 minus 3 times 10, or 2 minus 28. 2 minus 30, which is going to give me a -28. Now I'm one step closer to getting that identity matrix. I have 1, 0 going down. The next thing that I look at, I notice that I have a -7 right here. I want to transform that into a +1. So the next row operation that I'm going to do, I'm going to multiply the whole second row by a -1 over 7. That will give me that +1 that I need. So if I take row 2 and I multiply it by -1 over 7 times R2, I'll get that transformation that I need. So my new row 1 stays the same. So I have 1, 2, 10, but now I have 0, 1, and 4. Now I notice the last thing that I'm missing is I need to turn this 2 into a 0. So I need to do a row operation for row number 1. So my last operation is going to be row 1 is now going to be row 1 minus 2 times row 2. That will give me that 0 in that spot to get me that identity matrix. So now row 2 is going to stay the same, but row 1 is going to get that change. So 0 minus 1 minus 2 times 0 is going to give me 1. 2 minus 2 times 1 is going to give me that 0 that I need. And 10 minus 2 times 4, or 10 minus 8, is going to give me the 2. Now I notice that I have the identity matrix. So now I notice that I have just found x sub 1 and x sub 2. X sub 1 is equal to 2, and x sub 2 is equal to 4. And that is my final answer using Gaussian elimination.